Welcome back. Today we've got day 2. For today, you will be able to multiply or divide radicals and then simplify to simplest radical form. All right, that is our goal today. Now, order is important here, so we're going to multiply or divide and then simplify. All right, so here we go. Here are notes. We're going to try multiplying first. So the rules for multiplying, you're going to multiply the outsides, the coefficients together. Then you're going to multiply the insides, the radicands together. And finally, you're going to simplify at the end. Okay, once again, if you have your sticky note with your perfect squares, those might be helpful to have out today, so you might want to put those out in the corner of your paper. All right, let's go ahead and take a look here. So here we know we're multiplying. That's what the dot means. We have a radical and a radical. So when we multiply our radicals, we multiply the coefficients, the outsides together. So that will be the 3 and the 5. So 3 times 5 is 15. Then we're going to multiply the radicals together. So here we're going to have 2 and 14. So 2 times 14 is 28. After we multiply, step number 3 is to simplify the radical. So let's take a look. 28. We need to find a perfect square that divides into 28. Well, first, if we want to check, is radical 28 a perfect square? Nope, it's an irrational. It goes on forever and never repeats. So let's take a look here. What's a perfect square that goes into 28? Well, 25 does not go into 28. Let's take a look. 28 divided by 16? Nope. 28 divided by 9? Nope. How about 28 divided by 4? There we go. We've got it. It is 7. So let's take a look. I'm going to break down 28 into radical 7 times radical 4. And the 15 stays in the front. Remember, everything's being multiplied. 15 is going to stay the same. Radical 7 is not a perfect square, so that stays the same. Now, what is the square root of 4? Well, I can take the square root of 4, and it becomes 2. So the square root of 4, we hit enter, and we get a whole number 2. So then I'm going to multiply my whole numbers together. So 15 times 2, and we get 30 radical 7. And with that, we've got our first solution. All right, so let's go down now and let's practice a few multiplication problems. So number 1, we have a radical times a radical. So we're going to follow through the same rules. Multiply the outsides. 5 times 2 is 10. Multiply the radicands. So radical 3 times radical 2 is radical 6. Now, can we simplify radical 6? Is there a perfect square that goes into it? Nope. So that is our final answer. Okay, now let's try number 2. So we're multiplying, so we're going to follow the steps. Multiply the outsides. 3 times 2 is 6. Now we're going to multiply the insides, the radicands. So radical 6 times radical 3 is radical 18. Now, let's take a look. Is the square root of 18 a perfect square? Nope, it's irrational. So now we need to find a perfect square that goes into 18. And it's pretty easy to see. It's going to be 9. So if we take a look here, it's 2 times radical 9 times radical 2. The 6 stays the same. The square root of 9, if I plug it in my calculator, we get 3. So I'm going to go times 3. Now, I cannot take the square root of 2. It is not a perfect square. If I plug it in, I get an irrational, so it stays the same. And then I multiply the whole numbers together. 6 times 3 is 18, radical 2. And that's our final answer. Okay, now let's take a look at number 3. Now, I said up above, our goal today is to multiply. So let's take a look at number 3, because this one looks a little bit different. So now we have a number on the outside and then we have a binomial on the inside. So what do we have to do here to solve? That's correct. We're going to have to distribute. So 3 radical 5 is going to multiply to everything on the inside. So we are multiplying. So 3 radical 5 is going to get multiplied to 4 radical 6. The minus sign is going to stay the same. And then we're going to multiply 3 radical 5 times a whole number 10. So we're just going to have to multiply twice here. So let's go ahead. Remember, outside times outside, or coefficient times coefficient. 4 times 3 is 12. And then radical 5 times 6 is 30. Now when I come over here, the minus sign stays the same. Now on the outside, I have a whole number 3. Now is 10 a whole number or a radical? It's a whole number, so it's going to get multiplied to the 3. So then I have 30. Now 5 is a radical. There's no radical here, so it just stays the same. Now 30 is not a perfect square. It's not on my list. And if I take a look, there's no perfect squares that go into it. So it's going to stay just like that. And we cannot combine these because we're going to learn tomorrow that they are not common terms, because this is a radical 30 and a radical 5, so you cannot combine them. So we leave it as a binomial. All right, let's try one more like that. So let's take a look now at number 4. Okay, so once again, we have parentheses, and we're going to have to distribute to everything on the inside. So I'm going to take that 2 radical 3, and I'm going to multiply it to the 5. Then I'm going to have my subtraction symbol, and then I'm going to take my 2 radical 3, and I'm going to multiply it to 4 radical 7. Okay, now let's see what happens. So the 2 is a whole number, the 5 is a whole number, so they're going to multiply, so we get 10. Now radical 3 is the only radicand, so it has nothing else to multiply to, so it stays radical 3. The minus sign is going to come straight down, and now we're going to multiply the second set. So 2 times 4 is 8, and then 3 times 7 is 21. Now 21 is not a perfect square, it's not on our list. And there's no perfect square that goes into 21, so that's going to be our final answer here. Okay, next up, number 5. We have radical 5 times radical 5. Now they're both radicals, so it stays a radical, and we get the square root of 25. But wait a second, is 25 on our list of perfect squares? Yes, it is, and that is because the square root of 25 is... oops, it's 5. So this whole thing reduces and we get 5. Well, look at that. Radical 5 times radical 5, you get a whole number, 5. So let's see what happens if I try another one. So let's try radical 7 times radical 7. So radical times 7 times radical 7 is going to give us radical 49. Wait a second. 49's on my list. Let's take a look. The square root of 49 is 7. So we get 7. This whole thing cancels to 7. Are you starting to see the little trick here? So if I have radical 3 times radical 3, that's going to give me radical 9, and the square root of 9 is 3. So ladies and gentlemen, here is the rule. Whenever you multiply the same number, the same radical to itself, the square roots are going to cancel and you get that number. So in other words, instead of writing it twice, I could write it just once. So radical 5 squared, okay, the radical and the squared are going to cancel and you get just 5. But if you want to, you can keep it just like that. Now this works except when you have a coefficient in the front. So let's take a look at number 6. This one's a little bit different. So let's take a look here. We have parentheses and they are squared. So remember, what do you do whenever you square parentheses? That's right, you have to write it twice. 2 radical 15 times 2 radical 15. Okay, now we're going to multiply. So coefficient times coefficient, so we're going to get a 4. Radical times a radical, so if you want to, 15 times 15, we get radical 225. Now, if you're not sure if that's a perfect square, hopefully this is helping you out a little bit, but let's just double check. The square root of 225, oops, there we go. We hit enter and we get 15. So this whole thing cancels and we get 15. And then we multiply 4 times 15 and we get a solution of 60. And you have got it. All right, ladies and gentlemen, that is multiplying. Remember, you multiply first, simplify last. So let's flip it over now and let's spend the rest of our time talking about dividing our radicals. Now dividing is very similar to multiplying. You divide the coefficients together, divide the radicands together, and then simplify at the end. So here we're dividing. Instead of writing it out this way, I'm going to go ahead and I'm going to write it as a fraction because we know fractions are just division over 3 radical 2. I like to write it this way because then what I'm going to do is I'm just going to divide the numerator by the denominator. So let's take a look. Coefficient divided by coefficient. Negative 12 divided by positive 3 is going to give us a negative 4. And then you divide the radicals. Radical 24 divided by radical 2 is going to give us radical 12. Once we divide, step 3 is to simplify. So is there a perfect square that goes into 12? Right there, it's going to be 4. So negative 4 times radical 4 times radical 3. Now 4 is my perfect square, so I can take the square root of that and it gives me a perfect 2. And then times radical 3. So negative 4 times 2, we get negative 8 radical 3. And with that, we are done. All right, so let's go down now and let's try number 1. So here we're going to divide the radical by the radical, or sorry, the whole number by the whole number. So 12 divided by 6 is 2. Then you do the square root, and 10 divided by 2 is 5. Now 5 is not a perfect square and it can't be divided, so that is your final answer. Okay, next up, number 2. So here we go. So here we have a 4 and a 12. So 12 doesn't go into 4, but 4 goes into 12, or in other words, we need to reduce this fraction. So 4 divided by 12, math fraction, we get 1/3. So I can go ahead, this is going to be 1/3. And now we're going to divide the radicals. So radical 30 divided by radical 3 is going to give us a radical 10. I can either put that on the top or put it right next to it. So let me show you the other way you can write it. Or you could do radical 10 all over 3. Okay, and radical 10 cannot be simplified. Okay, let's take a look then at number 3. So first we're going to divide the whole numbers. So 16 divided by 8 is 2, and then 150 divided by 3, we get 50. So radical 50. Now radical 50, it's not a perfect square, but is there a perfect square that goes into radical 50? Well, I think 25 is going to work. So let's take a look. So we have 2 times radical 25 times radical 2. Now the square root of 25 is 5, so it's really 2 times 5 times radical 2, which is then going to give us 10 radical 2. And we've got our final answer there. Okay, next up, I'd like you to try number 4 on your own and then plug your answer in. Okay, let's take a look. When you divided, were you able to get 8 radical 16? And then 16 is a perfect square, so the square root of 16 is 4. 8 times 4 is 32, and we've got it. Okay, next up, let's take a look at number 5. I'd like you to try this divide and then simplify. Okay, when you plug your answer in the computer, I know there's no radical symbol on the computer, so just write the word radical where you need the radical to go. All right, let's see how you did. Were you able to get 5 radical 12? Break down the 12 to 4 and 3. The square root of 4 is 2, and then your final answer, 10 radical 3. Ladies and gentlemen, great job today. I will see you tomorrow in class.